Welcome to dxSudoku training video number 72. In this video, the skyscraper puzzle solving technique will be revisited, but this time using links, chains, and chutes in the discussion. This video has three prerequisite videos. The first is dxSudoku training video number 71 titled "Aw Shoot." The second is dxSudoku training video number 55 on the types of Sudoku links. And the third is dxSudoku training video number 27 on the skyscraper. This video has four parts. The first part is a discussion of the skyscraper pattern with chutes and links. The second part is a discussion of how the skyscraper logic works. The third part is an improved skyscraper search algorithm using chutes and links. And the fourth part is a discussion of how the skyscraper pattern is a variant of the X chain. Consider the following Sudoku in progress. All the cells having a possible 9 candidate are now highlighted. We find the skyscraper pattern now highlighted. A skyscraper pattern is composed of 4 cells and 4 separate 3x3 blocks. A skyscraper is known as a single-digit pattern. In this example, the skyscraper is using the possible 9 candidate as the single digit. It's certainly possible to have the 4 cells making up the skyscraper only occur in 2 separate 3x3 blocks. But simpler puzzle-solving techniques like lock candidates or a hidden single would be used before a skyscraper were found. In this example, we have 1 cell in block 1, 1 cell in block 3, 1 cell in block 4, and 1 cell in block 6. Each cell in each 3x3 block shares a chute with 2 other cells making up the pattern. For example, the cell in block 1 shares a chute with the cell in block 3 and a chute with the cell in block 4. Each of the 4 corners participates in 2 different chutes with 2 different corner cells. A skyscraper must have 2 sets of either/or links which are parallel to each other. At the base of the skyscraper, we can have either a bidirectional strong link or a bidirectional weak link. In this example, we have a bidirectional weak link. This is because having a possible 9 candidate in cell 5, 1 makes our base a bidirectional weak link. A skyscraper can have 4 different orientations. In this example, the skyscraper base is to the left. Here is an example of the skyscraper base at the bottom or right side up. Here is an example of the skyscraper base at the right. And here is an example of the skyscraper base at the top or upside down. We return to our original example of having the base to the left. At the other side of the pattern from the base, if both cells line up in the same column, we would have an X-wing. In this example, however, 1 cell is in column 7 and 1 cell is in column 9. The kill zone for the skyscraper is defined by the 2 corner cells that don't line up. The kill zone, now highlighted in red, are the cells sharing a house with each of the 2 offset corner cells. The target candidates to kill in the kill zone are highlighted in dark red. Each of the 2 kill zones is now outlined and can be considered to be a group link node. With each kill zone, the offsetting corners have a group weak link relationship with the kill zone as shown. What this means is, anytime either corner is set to a value of 9, or both, it results in the target candidates in our kill zone being killed. Now let's consider the logic for how the skyscraper works. To understand how the skyscraper works, we must consider each possibility for the 2 corners creating the kill zone. We begin with the first scenario. Cell 1, 7 has a value of 1. Since cell 1, 7 has a value of 1, then cell 1, 1 has a value of 9 because of the either/or link between the 2 cells. Since there is a weak link relationship between 1, 1 and cell 6, 1, and we have a value of 9 set in cell 1, 1, then cell 6, 1 cannot be 9. And if cell 6, 1 is not 9, then because of the either/or link relationship with cell 6, 9, then cell 6, 9 must have a value of 9 in it. And if cell 6, 9 has a value of 9 in it, then all the target candidates in the kill zone are killed. Next, we consider scenario number 2. This time, we have a value of 9 in cell 1, 7 as shown. With cell 1, 7 having a value of 9, all the target candidates in the kill zone are killed. Next, we consider scenario number 3 of having a value of 7 in cell 6, 9 as shown. Since cell 6, 9 has a value of 7, then cell 6, 1 has a value of 9 because of the either-or link between the two cells. Since there is a weak link relationship between 6, 1 and cell 1, 1, and we have a value of 9 set in 6, 1, then cell 1, 1 cannot be 9. And if cell 1, 1 is not 9, then cell 1, 7 must have a value of 9 in it because of the either-or link between the two cells. And if cell 1, 7 has a value of 9 in it, then all the target candidates in the kill zone are killed. Scenario 4 is similar to scenario 3, but this time we have an 8 in cell 6, 9 as shown. The same logic sequence results in having a 9 in cell 1, 7 as shown. And if cell 1, 7 has a value of 9 in it, then all the target candidates in the kill zone are killed. Here is the last scenario, which is scenario number 5. This time we have a value of 9 in cell 6, 9 as shown. With cell 6, 9 having a value of 9, all the target candidates in the kill zone are killed. So with all 5 possible values for cells 1, 7 and 6, 9, the result each time is our target candidates are being killed. So we must conclude our target candidates are non-possible candidates. We remove the non-possible candidates from the puzzle. Next, we are going to discuss an updated skyscraper search algorithm based on chutes and links. Consider the following Sudoku in progress. All the cells having a possible 5 candidate have been highlighted. We look for 2 pairs of cells having a set of parallel either-or links. We find a set of cells and we identify the 2 base cells of the skyscraper and make sure the cells are in the same chute. Next, we identify the 2 cells making up the kill zone are in the same chute. We identify the kill zone and target candidates to kill, and we remove the non-possible candidates from the puzzle. Here is the next example. All the cells having a possible 3 candidate have been highlighted. We find 2 sets of parallel either-or links. We identify the chute for the base cells. We identify the chute for the kill zone. Here is the kill zone and target candidates to kill. We remove the non-possible candidates. Here is the next example. All the cells having a possible 7 candidate have been highlighted. We find 2 sets of parallel either-or links. We identify the chute for the base cells. We identify the chute for the kill zone. Here is the kill zone and target candidates to kill. We remove the non-possible candidates. Here is the last example. All the cells having a possible 4 candidate have been highlighted. We find 2 sets of parallel either-or links. We identify the chute for the base cells. We identify the chute for the kill zone. Here is the kill zone and target candidates to kill. We remove the non-possible candidates. Next, we are going to demonstrate how the skyscraper is a variant of the X-chain. Consider the following Sudoku in progress. We return to our first example. Here is a diagram of the same skyscraper showing the link relationships between candidates within cells. As stated, a skyscraper is a variant of the X-chain. There are several different X-chain variants. Generally, when doing puzzles, I would purposely look for X-wings, skyscrapers, and two-string kites because they are so easy to spot. But I don't purposely look for turbot fish or empty rectangles. For turbot fish and empty rectangles, I just look for X-chains and find those two in the process. A turbot fish is just an X-chain with exactly 4 cells and 3 links. An empty rectangle is just an X-chain which has a single group node with 2 group links. We will now demonstrate the skyscraper example as an X-chain. All the cells having a possible 9 candidate are now highlighted in light green. We begin our X-chain sequence with the possible 9 candidate in cell 1, 7 now outlined. The next strong link in the sequence is a strong link between the possible 9 candidate in cell 1, 7 and the possible 9 candidate in cell 1, 1. The second link in the chain is a weak link between the possible 9 candidate in cell 1, 1 and the possible 9 candidate in cell 6, 1 now showing. The third link in the sequence is a strong link between the possible 9 candidate in cell 6, 1 and the possible 9 candidate in cell 6, 9 now outlined. As you know from the X-chain prerequisite video, after the third link, any cell seeing both a purple and green color outlined candidate is a non-possible candidate. Essentially, there's an either-or link between the starting cell and ending cell in the chaining sequence. The non-possible candidates are removed from the puzzle. This completes dxSudoku training video number 72. Please support dxSudoku. Thank you for watching.